Hi, so let me explain you the topic in detail word by word. So in this aerogel enhanced e-ink particle detector for thermospheric studies, we are focusing on two different technologies at one particular location. So the technologies are particle detector with a composite aerogel and e-ink, and the location is thermospheric space. So what we wanted to know first is what is a particle detector. So we have a very prominent particle detector in our planet, which is the Super Kamiokande, which is located in Japan. So which contains a unique device for detecting particles called photomultiplier tubes. These PMTs, photomultiplier tubes, are a part of the inner detector in the Super Kamiokande. So this person is holding it in his hand, and he is actually polishing it. It is about 39 meters diameter, the entire space, and it is about 41.4 meters in height, and inside which each photosensitive area is around 20 inches. So it's approximately about 50 centimeters. So it's a massive thing. It's made up of materials which are predominant for the photomultiplier materials. So the materials are basically acrylic, fiberglass shield, and there are also small metal matrix composites which are needed for detecting the change in the intensity of photons getting detected there. So this is all part of the inner detector, and with which we talk in detail about what the other part of this detector is about. So it is the outer detector, which is basically an opaque sheet, which is supposed to be about 1885 in numbers, and which are able to detect finer photons which are passing through this space of 60 by 60 centimeter space. So this is a ginormous thing. So all these things are in a scale of about 41 meters in height, and you can imagine the scale, even a tiny human can float inside it. So you can see these are the people who are servicing the photomultiplier tubes by floating inside this gigantic tank. This is the scale of their people. So now coming to the focus, you might ask, is there any other kind of experiment that is also happening in our United States? Yes, there is a similar kind of experiment which is happening in deep underground in a place called Dune. So the Dune is Sanford Underground Research Facility promoted by the Fermi Lab of USA, where this experiment is supposed to detect the same particles but in a horizontal orientation. So there is a mountain between the Sanford Underground Research Facility, SURF, and Fermi Lab, which is about 1300 kilometers, and from one location to the other they point the particles and they travel to a distance of around 1300 kilometers, and in a horizontal plane across the inner earth crust it travels, and with which we can able to detect the same thing using a photomultiplier tube on the other side of the experiment. So one side is vertical, that is coming from the space into the planet. So you can see this is the experimental way in which it is shown. So inside this mountain on a vertical plane is this photomultiplier tube, and the one that is getting constructed in the Dune space is this one, which is yet to be in development. So it will take another 5 years. So by 2030 or 2035 this experiment is going to be commissioned, and it is be running in the United States of America. So now coming to the topic of what all particles that we can see in the planet. See, there are lot of ejectional particles that are coming out of the planet. So from the magnetic core of our planet, lot of particles are emitted. So magnetic particles and magnetic charged waves are constantly propagating, and it is moving in our place. So this is in the relation to it, I show all the kinds of particles that are emitted from it. So we have neutral winds, you have protons coming from the energetic waves of the planet. So this is the planet, and based on the solar wind that is getting prominent on our planet, each particles are getting away and away from our planet space. So this is the theory of all the particles that are constantly emitted and what all interferences can it happen to our systems. So next comes the question, what is a thermosphere? So according to the scientific community, the thermosphere is the space between 100 to 180 kilometers or slightly above that, around 600 kilometers if you expand it to even the exosphere. It's the place where it is very extremely thin, but it is extremely bombarded with a lot of particles and lot of radiation. So ultraviolet rays and X-rays are constantly getting bombarded there, and with which a lot of interferences happen to every part of communication field. So this place, as you already know, is where our International Space Station is, and lot of low Earth orbit satellites are also there. So a lot of things on the radiation front is getting affected. Because of this, the thermosphere is of much more importance and much more significance. And you can see it's not only the place of extremes, it is also the place of extreme colds. So temperatures can go from minus 120 degrees Celsius to even as high as 2000 degrees Celsius if you have cascaded effect of higher solar radiation, higher solar winds at a particular place. So next, shifting our focus to the other part of our experiment. So this is our aerogel material. So in the aerogel material, you would see that it is being used in lot of industry, and each industry has significantly improved by use of this aerogel material. So this is very adherent to the temperature gradients. It is also used for specialized coating. It is used for insulation, because one side of the aerogel and the other side of the aerogel can have drastic effects based on the materials that are getting doped, and each scientist has contributed in enhancing its capabilities by having multiple composites added into it. So there has been studies about conduction, radiation, gaseous and thermal conduction, and a lot of this in the course of time. So the paper that you see here is by a CERN scientist, the Switzerland and Italian scientific community, which has found that the photon detection efficiency has improved phenomenally by having a doping effect of small particles. So I will tell you about it in the next phase of it. So the last thing I wanted to share is the electronic paper, the e-paper. So the e-paper is a electrophoretic display. It's a cascade kind of device, which you normally call it as e-paper ink or the Kindle device display, which has two things. Number one, it has a transparent electrode at top and bottom, and on the middle there is a pigment, which is a small magnetic pigment, which can able to give you a kind of an experimentation on what kind of particles are getting detected. So from top to bottom, it can able to change its phase based on the power efficiency that is getting posted in it. So it's a very low energy device, so with which we can able to detect a lot of power efficiency in it. So this is an experimentation which is conducted by NASA on the improvements of it. So you might ask, where does this come together? So our proposal is to have a particle detection system which can go directly into the satellite. So instead of building ginormous hardware like building a Super Kamiokande, which is about 40 meters, which is again a very huge device, and again a kind of an horizontal oriented 1300 kilometer or 800 mile long particle detector from one place to another in Fermi lab. All these things are complicated enough so that it will require a lot of real estate space. But space is where, I mean the outer space is where the particles are first getting to be known in our planet. So if you can detect it directly in that place itself, in the in situ area of the space on the thermosphere, you would able to know what kind of interactions it can able to cause for every living thing as well as the other non-living things like the satellites and satellite electronics. So we were able to read through a lot of scientific journals, and we can able to find that there has not been much interest in bringing these two wonder materials into the same space, because aerogel is a physics based material and e-ink is slightly electronics and electromechanical system. So there has not been much significance in bringing it together, But if we propose a device wherein which these two can be sandwiched together to make a kind of like a wondrous particle detector, which is very small in size and which is very huge amount of significance, because it is very less power consuming. Even your Kindle Paperweight or your Amazon Kindle can last for months and months without having the need to charge. And this kind of particles which are changing from color black to white is of much efficiency value. So if we can bring this together, and aerogel again is made up of 99% air or 98% air and just 1% of the material which is composites and doped into it. So if you can bring in the scientific development that is happening in the particle detector to the aerogel's intermediary, because what we are doing here is filling this entire 40-meter tube with water. So there is a lot of water filled into it, and there is a small amount of particle that is added, which is called gadolinium sulfate inside the water, so that even when small particles pass through this water, it will suddenly get bombarded with the heavier gadolinium, and it will scatter the light, and all the particle are getting captured or it is detected by the photomultiplier tubes. So instead of putting so much of real estate into all these things, we could make a very small tiny detector and put it inside a CubeSat and send it to space, with which we can able to revolutionize this particle detection directly in space as an in situ medium. So this is the efficiency in which we are hoping to work, and all these references and citations are given in the bottom, and each one of them is cited with the reference of where this research is going to take place.